Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Today I received a comment from one of my viewer, Rao Amarjeet. He asked me, can we test a gate drive pulse of IGBT with multimeter? In our last session, I discussed how we can test with digital oscilloscope. But today we will check it with a multimeter. Now I take out the negative return pulse from the emitter of the IGBT, and the yellow wire, it is connected to the gate. These two wires are connected directly to the gate. Yellow wire to the gate, that is connected to the high side signal. If we will connect reverse, it will not give a good duty cycle. Now we must understand that when we will apply power, we need a cooktop here, so that it first of all it will give a cookware identification pulse, that is just only one pulse, and it will receive the resonant signal from the resonant coil, from the induction coil and the resonant capacitor. If IGBT is good, coil is good, the capacitor is good, it will make a resonant circuit, so the processor will receive a echo pulse that the circuit is working good, and what is the size, what is the type of the cookware, it will detect, and then it will assign a duty cycle. It will calculate the duty cycle based on the cooking profile. If the IGBT is bad and we want to test without IGBT, in that case we must test with oscilloscope, which I checked in the last video. But if the IGBT is good, then we can verify the duty cycle. Connect these wires, the high side signal to the high side of the multimeter. I am using Unity 202A plus. It is a very commonly used clamp meter. I will use this one, or we can use another multimeter which have duty cycle and frequency option. I will apply power. In the first condition, I will set multimeter to Hertz, and now I will power on. When I will power on, it will not detect anything, and the induction cooker is giving E0 error. That means no cookware detected. Power off. I will place this cookware. Power on. At 2000 watt, it is giving 29.29 kilohertz frequency. And if I will switch to the second menu, that is the percent menu, that is the duty cycle menu, it is switching at 35.8%. Okay, let's reduce the temperature. At 400 it will turn on at 32%, and then it will turn off to maintain the temperature. Now I will increase the temperature again, 800 watts, 1200 watts. So it is switching at 31.8%, and the switching frequency, that is 30.37 kilohertz. If I will increase the wattage again, the switching frequency is 29.94 and the duty cycle 32.9. In this way we can verify the duty cycle. If I change the cooking profile at 2500, the duty cycle change. If I select it so, the duty cycle dropped. If I will select it to cook hot pot, so it will adjust the duty cycle based on the cooking profile. 1200, 800 watts. So the duty cycle dropped at 31%, 32%. But for different cooking profiles, the microprocessor will adjust its duty cycle to achieve the heat. If you will reverse the leads, now let's come to the second question, which I said, if you will reverse the leads, what will happen? It will show false reading 63%. That is not good. Why? We connected the low side to the signal point and signal point to the common. It is the good value, and we can also verify with the oscilloscope. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.